Okay, so in this video we're going to integrate e to the x cosine x with respect to x. So we've clearly got two terms here, the cosine x and e to the x. So this question is going to be integration by parts. So straight off we'll go straight to the formula for integration by parts. So the integral of u dv equals uv minus integral of v du. Okay, so what we have to do next, assign a u to one of these and a v to the other one. So let's go straight into that. So u, we can just let that be e to the x, and the dv will be cosine x. Okay, now looking at this formula here now, we need a v and a du. So straight off to the du, that's the differential of e to the x, which is still e to the x dx. That's straightforward. So now we need to find the v from the dv. So basically all we need to do now is integrate cosine of x, which we know is sine of x. So that takes care of that. So let's just put that in a box. Okay, so now we're going to imply all these things into this formula and see where it takes us. So sticking with the question, so e to the x cosine of x. So where u and dv is these ones, that's simply what we got here. And then equals u times v, e to the x sine x, minus integral v times du. So that's sine x times e to the x dx. Now just allow me to put the e to the x before the sine x and then the dx. So we're in the same format as what we got here. Stops us getting confused. So e to the x sine x dx. Okay, so there's our question. This is part of our answer. But I see as part of our answer as well, we've also got this integral again, and it's similar format to this one. So now we've got integration by parts again, which we call integration by parts twice. So now we've got a new integral to work out. So with this one, same format is applied here. So this is the first, and now we're going to do another box for the second. So straight onto that, let's work out our u's and our dv's. So again, u, we can apply e to the x as we did in the first one. And our dv, well, that's going to be our sine x. So now we need our du and our v. Okay, so the du is going to be the same as in the first one because it's e to the x, same again. So e to the x dx. Everyone's favourite differential, and v is basically the integral of sine x. So the integral of sine x is negative cosine x. Okay, so now we've got this box, we can just implement this formula and off we go again. So now let's start our line again. So the integral e to the x cosine of x dx, forget the dx here, that's naughty, e to the x sine x minus, now going to implement all this here now. So this here now will be in brackets. So u times v, so it's e to the x times minus cosine x. So I'm just going to write that as minus e to the x cosine x. So let's not get mixed up with this minus sign. So minus e to the x cosine of x. And then again another integral. So minus, let's put that here so we can fit it in, the integral of v times du, which is minus cosine x e to the x dx. So again, I'm just going to bring the minus out to the front and the e to the x out to the front. So minus e to the x cosine x dx. And again, end off, closing off the bracket. Okay, so now if you look carefully, got a few minus signs here where we need to be a little bit careful. Okay, let's go for that. Let's just simplify this up, and because that's quite long, let's bring it out here. So integral e to the x cosine of x dx equals, it's part of the answer, that stays, e to the x sine x. Okay, now let's go for what we've got inside this square bracket. So we've got minus e to the x cosine of x as part of our answer, but then there's another minus at the front of the brackets, so therefore two minuses make a plus, so we're going to add e to the x cosine of x. And then we've got a minus, a minus and a minus for this one, for this integral, which we need to do again, is a minus, 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 that still stays as a minus. So that's minus the integral, and then this minus is taken out and used applied with this one. So now we can just write e to the x cosine of x dx. Okay, and that takes care of all the square bracket. Okay, so now we've got another integration by parts, but if we look carefully, it's the same as the original question. So we've got an e to the x cosine of x dx here, and e to the x cosine of x dx here, with a minus sign in front on this side. So what we can do, if we add the integral e to the x cosine of x dx to both sides, this we can stay as it is. Basically what we end up with now, these will cancel out, and then we'll end up with 2 to start with. So now we'll have 2 times the integral e to the x cosine x dx equals this part. So let me just factor out the e to x. This makes it a little bit neater looking. So e to the x sine x plus cosine x. So if you FOIL that out, you end up back to there, e to the x sine x, e to the x cosine x. Okay, so we're still not quite there yet. So we've got 2 times the integral here equals this. So if we just divide each side by 2, we end up with the integral e to the x cosine of x dx equals e to the x over 2. Again, we divide this by 2, so we need to divide all this by 2. Sine x plus cosine x, and then plus c. Okay, so that is our answer. There we go.